Okay, in this video we're going to be talking about ratios, proportions, and similar polygons that we're going to find scale factors of. So when we're talking about ratios, we're comparing two quantities using division. So we could do in words, so 3 girls to 4 boys. My two quantities are 3 and 4. We could use a colon, or we could use a fraction. So 3 to 4, 3 to 4. Okay, so if we're simplifying these ratios, these are all fraction ratios, we need to make sure both that they're first in the same measurement here, and these ones are, so they would cancel on top and bottom because they're the same on the top, same on the bottom. If I simplified 6 over 12, my ratio would be 1/2. Okay, if I look at the bottom, at the top here, I wrote this. So there are 12 inches in each 1 foot. So right now on my top, I'm converting to inches to get them to be the same. So if I think about it, if I have 4 feet, each one of them has 12 inches. My total, if I added all those up, would be 48. So it's the same as multiplying this by 12 to get 48 inches. Now they're in the same terms, so my inches will cancel. I can take 48 divided by 16 and get 3 as my ratio. Okay, my next one, I want to go to inches because it's easier to expand yards going to inches than it is to go and get some decimals. Okay, so first we need to get to feet. So there are 3 feet per 1 yard, so if I multiply this by 3, I should get how many feet? And then I need to get from feet to inches. Well, we already discovered there are 12 inches in each foot, so if I multiply this by 12, I should get my inches. So it cancels on top and bottom. 144 divided by 18 is just 3. Okay, extended ratios when we're comparing 3 or more numbers. Okay, so I got 3, 4, and 5 in this, so we're comparing 3 different numbers. So the ratio of boy giraffes to girl giraffes is 3 to 4. If there are 35, how many boys are there? So it's written respectively. We said boys to girls, so this is my boys, this is my girls. Whenever I give you a total, okay, what we're going to do is we're going to add them together. So 3x plus 4x equals 35. Okay, we keep the same variable because now when I add them and divide by 7, I know my x is equal to 5. Well, that tells me x. It doesn't tell me how many boys or girls we have. So if I plug it back in for my x, I should be able to. Well, the one I really care about is boy giraffes, so I want to plug it into 3. 3 times 5 gets me 15. So I have 15 boy giraffes. Okay, I'm going to erase this so I can go to the next one. The ratio of width to length, so this is width, this is length. If the perimeter of a rectangle is 40 centimeters. So perimeter means when we add up all the sides of my rectangle. Okay, so I have 2 widths and I have 2 lengths. So when I add up all the sides, I need to include 2 widths, so 2 widths and 2 lengths. Oops. So 3x and 3x equaling my perimeter. Because perimeter is when we add up all the sides. So we're adding width and width, length and length. So 2x plus 2x gets me 4x, plus 3x gets me 7x, plus 3x gets me 10x. Divide by 10. So x is equal to 4, but I want to know my width and length. Okay, I only care about knowing one of them, so I need to only plug it in for one set of each. Okay, so if I plug it in for, we're doing width here, I get 2 times 4, which is 8 centimeters. So there's my first answer, and then when I do length, I have 3 times x, so 3 times 4, which is 12 centimeters. So anytime I give you a total number, we're adding them and setting it equal to it. So for my next one, the measures of the angles of a triangle of the extended ratio is 1, 2, 3. So this is my first angle, second angle, third angle. Find the measure of each angle. So when I'm talking about angles of a triangle, and I'm talking about all the angles in it, all the angles should add to be 180 degrees. So I'm giving you a total again. You just have to think about the fact that all angles in a triangle add to be 180. So if I do 1x plus 2x plus 3x, because all angles added together should be 180 degrees in my triangle. So if I add this, 1x plus 2x is 3x, 3x plus 3x is 6x. If I divide by 6, x is going to equal 30. Now we got to find the angle, so we're going to plug it back in. So 30 times 1 gets me 30. 2 times 30 gets me 60. And 3 times 30 gets me 90. And if you check, if I add all three of those together, it should equal 180 degrees. Okay? When I have two ratios set equal to each other, so we're creating fractions out of these, we're going to be using cross multiplying to be able to solve them when I'm giving you x's and y's. So an example with an x and y, when we cross multiply, I take 9 times 6, I drop my equal sign in the center, and I do 24 times x. We are cross multiplying, and we drop the equal sign in the center. So 9 times 6 is 54. And then we have to divide by 24 to get rid of it. So my answer looks something like that. You could simplify your fraction or give me the decimal. I don't really care. Okay. You could also see other forms that look like this. Okay. So we could be adding whatever is on the bottom to the top, bottom to the top. We could be flip-flopping things. Okay, so your proportions could be the exact same, but flip-flopping some. So an example, if I go from A to B equals 3 to 4, so I start with this, what changed when I did this? Well, it looks like they flip-flopped the left side, so to get my other half, I need to flip-flop my right side. So 4 over 3. So you're kind of figuring out what changed from one step to the next step. Okay, similar polygons, when we're talking about similar polygons, with the same shape but not the same size, okay? So they could be the exact same shape, but one's a little bit bigger and one's a little bit smaller. So you can see that these both are the exact same shape, one's a little bigger. Exact same shape, one's a little smaller, okay? Just a quick, if I go back to this, if I had an example that was like x plus 1 over 3 equals 2 over 9, if I cross multiplied this, 3 times 2 gets me 6. When I do the 9 on this side, I need to multiply it by the entire thing on the top, not just part of it. So when I distribute, I get 9x plus 9. So be wary, you have to multiply it by the entire thing that it's being cross-multiplied to. So in this situation, I would subtract 9 to get negative 3, and then divide by 9 to get negative 3 over 9. Okay, so if I cross-multiply, do it to the entire thing that it's cross-multiplying to. Okay, so let's go back to similar polygons here. Okay, some non-similar polygons. Okay, if you look, this looks more of like a square, and this is a rectangle. They're not the same shape. If we look at this, you could see how much longer these sides are and how much fatter this is. They're not the same shape. Okay, so they're not similar. This looks like it's got all equal sides. This definitely does not have all congruent equal sides. So they're not similar. Okay, properties of being similar polygons, they have to have the same number of sides. Okay, so these triangles both have 3 sides. They have to have corresponding angles congruent. So the angles that match up to each other are congruent. So angle C matches with angle M. It looks like B matches with O, and then these ones match. Okay, so the corresponding angles will be congruent, and then the corresponding sides are proportional. They don't have to be congruent, they have to be proportional. And I'll show you what that means in a second. So when we write similarity statements, we write them with this little squiggly. So if I was saying, in this situation, triangle ABC is similar to triangle A matches with M, B matches with O, and then we have N left. So we use this statement to say similar instead of congruent. Okay, scale, a ratio that compares each length in the drawing to the actual length. Okay, so when we're scaling something, we're either making the figure bigger or smaller. Okay, so to be able to do this, first we need to check to see if it's similar. So my first step, same number of sides. Okay, my second step, angles, the corresponding angles being congruent, and my third step is to check to see if the sides are proportional. Sides proportional. Okay, so same number of sides. Okay, cool. We have the same number of sides. Looks like my corresponding angles are all right angles, so we're good. Now we got to check to see if our sides are proportional. So when I write my proportion, we start with one side. So let's say we pick 4 of this one. We have to match it to the other one, 3. Okay, so I started with this one, so I need to start with this one again with 10 on top. The same figure goes on top for both of them. The same figure goes on bottom for both of them. Okay, so 10 matches with 8 on my other figure. To see if they're proportional, proportional means They should be the exact same. Okay, it should say 4 equals 4 or 1.2 equals 1.2 for it to be proportional. So if I take 4 divided by 3, I get 1.33. If I take 10 divided by 8, I get 1.25. If they are not the same, they are not similar because they are not proportional. Okay, for this one, we're saying they're similar, so now we're just going to state all the things. So first off, they both have 4 sides, so now we can say their angles are congruent. So A matches with W, B is going to match with angle X, angle C here matches with angle Y, and then angle D matches with angle Z. Then we can say all the sides are proportional. So if I do AB matches with WX, so that's why they did the first one. And then the next one they said was BC matching with this. So my next set, let's go ahead and pick DC, and it matches with ZY. And then my last set, we could say AD, and it matches with WZ. Okay, they have equal signs in here because when we set up the proportions, they should all be equal, meaning we're scaling by the same size on all 4 sides. Okay, so are these polygons similar? First off, do they both have 3 sides? Yes. Do they both have sets of congruent angles corresponding to each other? Yes. So now we got to check to see if they're proportional. So let's say I start with this one. So we'll put 60. 30. What matches with 60? Looks like 36. I started with this triangle, so I need to keep starting with this triangle on top. So 40 looks like it matches with 24. And then 30 matches with 18. So for it to be similar, these all need to be the same. So this, when I divide it, gets me 1.67. This, when I divide it, gets me 1.67. And this also gets me 1.67. So yes, they're similar. So if we're writing a similarity statement, we could say triangle LKM is similar to triangle L matches with R, K matches with Q, and then we have S left. Okay, if it was asking for the scale factor, we're going to be talking about that in a second here. Okay, are these rectangles similar? So first off, do they have the same number of sides? They both have 4. It looks like all of them have right angles, so their corresponding sides are congruent. So let's check our proportion. If I start with 15, 15 matches with 20 on my other one. Then 10 matches with 12. 15 divided by 20 gets me 0.75. 10 divided by 12 gets me 0.83. So no, they are not similar. Okay, give the scale factor and find x. So first off, finding x, we got to set up the proportions to find it. So if I have, let's start with 4. 4 matches with 2.4. If I'm finding x, I need x in my problem. So my next set I want to pick is the one that has x in it. So 6, which matches with x. So I'm going to cross multiply to solve it. So I got 4x, drop my equal sign in the center. 6 times 2.4, which gets me 14.4, divide by 4. So x is equal to 3.6. So I'm going to take this x out and put 3.6 in. Okay, now it says ABCD is similar to NMPO. So this basically tells me my direction I go. So I'm going from this to this. So am I getting bigger or smaller? It looks like I'm getting bigger or smaller. So if I'm getting smaller, my scale factor should be smaller. And the reason for this, if I go back to this, I'm going to erase this. If I have triangles and I go from this to this, or this to this, oh, that was a bad one. If I'm going from this triangle to this triangle, I am getting smaller. So my scale factor needs to be something small. So if I take 4 and I times it by 0.5, that's cutting it in half. So your scale factor needs to be smaller to make it get smaller. Okay? If I'm going from this triangle to this triangle, I am getting bigger. So I need my scale factor to be bigger. So if I think about it, if I have one side being 3 and my scale factor is 2, so if I multiply that times 2, I get 6. So it's getting bigger if I multiply it by something bigger than 1. So this one we want it to be bigger than 1. And this needs to be less than 1, so smaller than 1. Okay, to make it get smaller, we have to multiply it by a small decimal. To make it get bigger, we need to multiply it by a number that's bigger than 1. Okay, so if I go back, we're getting smaller, or you could look, I'm going from 4 to 2.4, so I need to be getting smaller. So my scale factor needs to be smaller than 1. It needs to be small. Okay, so to get scale factor, we got to set up our proportions. So let's say we pick 4. 4 matches with 2.4. 5 matches with 3. And 6 matches with 3.6. So I'm going to go ahead and divide them. They should all be the same. So I got 1.67, 1.67, and 1.67. Okay? Problem is, if that's my scale factor, so they're all scaling by 1.67, is that going to make my figure bigger or smaller? It's going to make it bigger. I needed a scale factor that makes it smaller. So what I need to do is flip all of my fractions, because I could have started with my teeny figure on top. So I'm going to flip this to 2.4 over 4, 3 over 5, and 3.6 over 6. So starting with my teeny one on top. So if I do 2.4 divided by 4, I get 0.6. I get 0.6 again, and 0.6 again. That's the scale factor I want, because scaling by 0.6, if I multiply by 0.6, it will get my figure to become smaller. So my next one, well, we got to solve for x. So I'm going to do 14, which matches with 9.8, equals 11.5, which matches with x. So I cross multiply, I got 14x equals 9.8 times 14 matches with 9.8. 9.8 times 11.5, I get 112.7. Divide by 14. So x is equal to 8.05. So I'm going to remove x and put my actual number in. So when I set up my proportion, I'm going from LMNO to RQTS. So if I look, I'm going from 14 to 9.8. So I'm getting smaller. So I need my scale factor to be small. Okay, so when I set it up, if I go 9.8 matches with 14, 8.05 matches with 11.5, so if I divide them, I get 0.7 is equal to 0.7. That is a small scale factor because I'm scaling by 0.7, so that's the one I wanted. If I would have got something bigger than 1, I would have needed to flip-flop my fractions because I wanted to start with my teeny one on top instead of my big one. So my scale factor this time is 0.7.